Okay, so sound and the stream video both seem to be working, so let's get started. Thank you all for coming. This is Bence. You can find me on Discord and Twitter as well. Yeah, many of you have been wondering how to pronounce my Discord username, so I'll just say it once. It's Junec, but that's fairly Hungarian, so you don't have to use that. You can keep using DZ or Bence. So you are probably here to win this game jam, so either this tutorial is for everyone, but I would like to talk to the people who would like to actually win this thing, and the way I approached it in my previous game jam entries is to really think outside of the box, outside the parcel. Yeah, it's a cheap joke, but really you have to push your limits and push the limits of the SDK, and that will catch the eye of all the judges. So that was my approach, and to push the limits, well, with my very first entry I entered with a robotic spider, and the thing I saw was that everything was too static. You walk around the scenes and everything just stopped. It froze. The whole world froze. So I thought to myself, okay, and whatever I build, it has to be dynamic. It has to move. So that was the number one rule there. But then I ran into a problem of not finishing the game in time. So that's also something to consider, that I spent way too much time on technicalities of the animated spider, and then not having enough time for the gameplay. So then I entered the builder contest with the first version of the Moonshot Stadium, and there I also tried to push the limits with moving the ball together with smart item boxes, so you could kick it in any direction, and it was quite complex. I actually made it so that you can score a goal and the goal counters would notice you scoring a goal and using only smart items. And yeah, well, it was also a really technical challenge. And then came the Infinity Engine, which brought me my breakthrough, and I was noticed by the Decentraland team, which probably was the project that pushed the limits the most, because I thought that, okay, everyone has a small parcel, everything is limited and scarce, so what if we could make the game inside the parcel bigger? So this was the whole concept, to make the inside of the parcel bigger than it looks outside. So these are just, case studies of previous games. And Infinity Engine became a launch title, but soon after launch I realized that the true value in Decentraland lies in multiplayer. So if you just play around single player games, then it gets lonely. So it's also kind of static, because it's not social dynamics are missing, so to say. So I went back to do a multiplayer game, and there I also had to invent some stuff to get around some limitations of the SDK, but it was always solvable. So I took it as a challenge, and even though the default multiplayer peer-to-peer protocol was slow, I decided to add these extra astronauts, and those were synced across all realms and updated much faster, so you could actually play the game and not miss out on the ball's position and the other players' positions. And just a sneak peek, it's Decentraland. That's my next Mario Kart type game, which is coming soon, and I'll try to put all the above in there. So it should be a really dynamic, fast-paced game, multiplayer, and it should scale down to a single parcel, and it will use the Infinity Engine. Yeah, it's gonna be tough, but hope it will happen. And also, just a reminder that Decentraland is more than a game. So the projects I liked personally are the ones that are trying to combine the Decentraland scene with other crypto projects and games. So NFTs really can make this happen. We could share game assets between games, and especially inside Decentraland, there could be many interesting projects that work throughout the whole world using NFTs, like, I don't know, game of tags or battle royales that spread out to the whole world. So if you are able to think ideas along these lines, that would also give you some advantage in the game jam. And so yeah, pushing the limits, but also having limits is a huge thing for me, because usually what happens is an artist just stares at a blank page and doesn't know what to build, what to do. But instantly, as you have some limits or rules or restrictions, then you can think about those, and you already have some level of guidance, like what you see here. You can ask yourself, what can I fit into 10,000 triangles? How could I get the most out of them? You could have 10,000 separate triangles in a single parcel, so you could make, I don't know, confetti or fireworks, and it would be amazing, because that's a lot of triangles, and it would look pretty. So obviously you can build a AAA game in 10,000 triangles, but still you can be creative with them. So I think that's a nice approach. And so yeah, you cannot build a AAA game, but you can certainly scale with having more parcels. So always try to match the art style to the polygon budget that you have and the texture budgets that you have. Meaning that a lot of people don't know that that multiple art styles can be achieved. So the default low poly single color objects that you see around Decentraland are really nice art style, but everyone is complaining that it's so simplistic. But little people know that physically based rendering is fully available inside Decentraland. So using metallic and roughness and normal maps and other textures, you can achieve really photorealistic objects as well. Of course, they use up more of your budget, so if you are building for a single parcel, then it's probably not a good idea to have like 5 textures per object in your scene. So you could go for a cartoonish style, or more like the default Decentraland style. But if you scale up your parcels in that state, you can go for a much more dynamic or physically accurate look. And also you can add whole skyboxes, so you can block out the default sky and make night, like the Salmonomicon game did with their horror title. And it was an excellent idea, so they actually made the game at night. And yeah, I can't stress this enough. This is my most important rule. Everything should move stuff as much as you can. And if you can move it from code, then it's even better, because then you don't really have the limitations of the polygons. You can move stuff from code, like an object could react and wiggle when you click it, or the trees or grass blades could have a little swinging. You could have NPCs that move around and talk to you, like, you know, the Viking gym game has a really good example where they added this receptionist Viking who accepts you and talking to you, and it adds a lot. So if the whole scene was static, it would feel a lot less alive. And be aware of the tool Mixamo, because it's basically a zero effort animation tool. You can just upload your humanoid model, and with 3 clicks you could download animations and import them into Blender. So yeah, that's a great tool to have if you want to add movable NPCs. But yeah, so along these lines I will now try to go for the code and build a scene where objects can follow you around. So I could prove my point that it can be a game changer. So yeah, first of all, let's look at the final example. I don't know if you can see this, but I hope it goes through the stream as well. We had a lot of little axes. They're all gathered around that spot. If I press E on the keyboard, they start following me and gather around me, all just smiling and really happy. And you know, I can boss them around, like clicking somewhere and then marking that spot, and they would all go there, bouncing along the way and then stopping their bounces once they get near the point. So we'll try to get as close as possible to this in today's tutorial. Yeah, so let's get into it with the basics. So all the tutorials and all Decentraland docs, you know, start with telling you that, yeah, you should first of all install Node.js. So Node.js is absolutely essential. All the other commands that the documents list will not be available if you don't have Node.js installed. So that's the first to have, and the second one is the editor I prefer is Visual Studio Code, which you can easily install after a Google search. So Visual Studio Code, as you can see right here. And if you have both of them, open up Visual Studio Code. You can just have a terminal and start a new terminal here, and that will basically pop up right in the bottom. And that's where you type all these comments. So all the comments that are listed on the doc site, like DCL init or DCL start, should be written in the terminal here. And once you have that, you should just create a folder. You can create a simple folder on your machine, and then file and open folder, open up that specific one, Workshop Live. And once you are in there, you can do DCL init and then DCL start to check out what's happening, because DCL init gives you a basic scene that you can start exploring. And DCL start will also start your browser if everything is going fine. So yeah, how to approach this problem. So once you have everything set up and you are here within the source folder and game.ts file that was created for you, you can just go in and write a bunch of stuff. So if you have default code here, you can go ahead and delete that. We'll try to first build the logic behind the scene. So we try to have objects, which are now axes, to follow you around. So you will definitely need some assets to load. These will be like the GLBs or textures that you need. We'll most probably have entities, and to be dynamic, we'll definitely need systems. Yep, so entities are pretty much a coder's way of saying things. So when you create an entity, it becomes something. It's not visible anywhere. You have to attach attributes to it in order to become visible, and then you have to add it to the engine in order for it to show up. So now I'll use my cheat sheet and get in just the first shape. So inside your projects folder, you should create a models folder and just download into that models folder any kind of GLB you could grab, or if you have axes, these will be available after this tutorial. You could easily download them and just include it in your models folder. And so this way, when you when you load the shape into the SDK, it will be right there for you, just with a local reference to it. So how do you create an entity? Well, just create our first axis. It should be an entity, and this, as I said, won't show up yet, so you have to add a bunch of attributes to it. If you want to have position, you should add a component called transform. This will be definitely needed, as we want to transform it. It won't be static, you have to move it on every frame, so we need a transform component. Then we'll add this shape component that we just loaded in. And then we'll add it to the engine. So engine.add axis. Add entity axis. So with this basic setup and doing DCL start, we should already have an axis that has a position in world, probably out of bounds, but we'll see. Yep, so there it is, our first axis at 0, 0, and the SDK is displaying me that it's out of bounds. So anytime you add the component, the transform component, you can add the default values. So we'll add the default position that is not out of bounds. So we'll create a new vector which will have coordinates that are just inbound. So the scene is one parcel that's 16 by 16, so the center would be 8 ground level and 8, so on the X and the Z axis it should be on the center of the scene. So now when I save it, it should update and it's already there. After a refresh, the red marker goes away, so it's cached as out of bounds. We should remove that with a simple reload. Okay, so we have an axis. It's moving already, but because the animation is included in the GLB, so don't be fooled, we didn't write any code that moves the axis. It's pretty much standing there, and that's our whole scene. So how will we tell which objects to move and which objects to not move? We could add a system that goes for this directly declared axis here and then tries to move it, but we want to be able to attach the player following attribute to it. So if you put in another object or include a box or something and you want that to follow us, it should be an attachable component. So you can also write custom components for yourself, in which case we will do a player following component. Yeah, so this is the syntax. It will have this name and it is a class, and it will be completely empty first. This is basically just a flag that you can attach to your object. So you can add this flag, and then you can, in the system later on, you can ask for all objects that have this flag. So it will be really useful to separate it from other objects and have lists that contain different groups of objects based on these flags. So we should add a new follows player component. Alright, so now it's time to do something dynamic, and when you do something dynamic, it always comes down to systems. You add a system has an update function which the SDK runs every frame. So you can be sure that if you create a new system, whoops, hey, sorry about that. You add the system, and it will basically have this function by default, and it will have an input with the time that's passed between two frames. You have access to that inside of your function, and that's it. You can be sure that whatever you write here, you will see it happen every frame. Anything else you add outside the system, like adding these components here, will only happen once as the code runs from top to bottom. But inside here, this will run on every frame. So it can also hold variables, so the system will include a group of objects that has the follows player component which we created. This group also behind the scenes updates automatically, so it will always have all the objects. Even if you remove the component from an object, this group will update automatically, and you'll only have fewer objects listed here. And then inside the update function, what we want to do is basically go through all of these objects in this group and then update them to follow us. So we will do exactly that. I will bring in a cycle that goes through a group. This is a for cycle, or a for loop, sorry. And the for loop will go through the group entities. So this, the word this in this case means the class we are inside of. It includes a variable called group, which includes entities. And so this loop will go through every entity inside that group. And now I can be sure that every entity here will have this flag. So let's start with something simple, like we should get access to the player's position. In order to do that, we're gonna add some globals and just get the player's position, which is in the SDK stored in the camera instance. So once you have that, you have a variable called player, and if you write player and put a dot, you can see that you have access to the avatar's feet position, or how high they are, their head position, or basically the camera position, rotation, and so on. So this is perfect, since we want to follow the player. So what should we do with it? We could do get the first, or get the axis, get its transform component, since we want to move or rotate it, and then set the position to be equal to the player's position. So what will happen now? If you do this, whoops, then basically nothing happens, and that is because people always follow to add their systems after creating them. So just like adding entities to the engine, systems will only work if they are added. This way you can pause them by removing and re-adding them and so on, but nevertheless you need to add the system and create a new player follow system. Yeah, so what happened here? We just made a new variable, right? So the axis, well, sort of following me, but it's following me way too fast. It's always on every frame instantly moved to my head position. So this is not gonna work. We want it to be somewhat realistic, want it to be nice, want it to follow you around and jump around you and so on. So it's definitely not good if it's instant. What we can do instead is just calculate a direction to move, but don't move all the way around. I don't know how to do this, but basically you have the position of the axis, you have the position of the player, and right now it jumps straight here. What we want to do instead is to have the axis and the player, and you want to have only this direction, but then have it way smaller, so on each frame only step a small percentage of that. And in order to do that, we'll need to calculate that that vector between player and the axis. And to do that, we are going to get the transform of the axis into a variable. So it's the same as before, but we just want to reuse it multiple times, so we load it here. You want to get the you want to get oh, the player position we already have. Yep. So these are the two. So what's the vector between those two? It's always a subtraction. So we'll create a move direction vector, and it should be the player position oh no, sorry. It should be the axis position and subtract from it. Oops. Oh no, I messed it up. So it should be the transform position of the axis subtracted from the player position. This way you'll get this whole vector again. And now we want to normalize it, so it has a length of exactly 1. And then we want to give it some sort of a speed. So now, because this is now exactly the length of 1, on every frame it will move 1 meter, but we want it to be even less, so you can multiply the vector with floats, and let's say, I don't know, it will be like 10 centimeters on each frame. And then just have the axis transform position and add the move direction vector. So let's see if it changes anything. Oops, no, it still moves way too much. That's because in the speed here we should also include the time that passed by between 2 frames. Otherwise, otherwise a faster machine would move it more. So during 1 second it would move 60 times this 10 centimeters. The slower machine would barely move it, as it would only render like 20 frames a second, so 20 times 10 centimeters. No. Normalize probably does not work in this way. So it doesn't directly apply to this. I have to make an equal sign that update the move direction with its normalized version and multiply it. Let me hide this quickly. Okay. Okay, so now it's moving, but it's way too slow. You probably cannot see it. So that means probably, yeah, the delta time is a very, very small number. So it's definitely not seconds, but 0.000 something. So let's try a speed of 2. Oops. Oh, yay. Okay. So on every frame we are calculating a vector between the player and the axis and move along that vector, but only with a speed controlled factor. So don't move all the way on every frame, don't make it into an axis hat. You just calculate the direction, which is this part. Subtracting 2 vectors, you get the vector between them. And then you normalize it to make it the length of 1. And after you have it a length of 1, you can set it to any speed easily. Just by multiplying that, you can have direct control of the axis speed. It will always try to move towards the player position, but only by such and such amount each frame. Yeah, but so it's coming backwards. How could you rotate it? Well, you have so many options to rotate it. You could instantly give it a built-in billboard component, and that will make it look towards the player. We're not going to do that though, because if you see the original example, you can have them commanded like so. So you don't always want them to look at the player, but you want them to look at the target point. So in order to do that, we'll do something called look at. So we move the axis, but we also want to transform that look at and give it a point, which is right now can be the player's position, that's fine, or player's feet position. So they are always looked towards that, and that's it, one line, and the axis will turn towards you. Hopefully. Let's see after refresh. Yep. Here it is. Smiling or whatever he's doing. Always looking at me. Kinda creepy. Okay. But here you have a basic follow system. So it looks at you and it calculates the movement vector and moves with a constant speed. You can speed it up, slow it down. That's it. So, what's the first problem you run into? Well, we are in Decentraland, so you probably only have a few parcels. And that means if you go further than your parcel, it will follow you there as well. But it will definitely be banned in the future from Decentraland this way, so it's not something good to do. So what we do is restrict it to the boundaries. We know that it's 16 by 16 meters, so it's easy to set it up now directly. We will create some boundaries first. Let me grab those from my little cheat sheet. And what we'll do here is have a boundary maximum and minimum along the x-axis and also along the z-axis. So the maximum would be 60 meters and the minimum would be 0, but since the axis has a certain size, we don't want half of the axis to just be outside of the scene, so we have a safe boundary here. So instead of letting the axis go all the way to the edge of the thing, we have a radius, a safe radius of 3 meters around the borders. So these are just global variables that you can access. You don't, it will not do anything with the scene just yet, but inside the system we can set this up. So instead of moving the axis right away, we should first check whether we can move there. So let's have a next position first calculated, which should be a temporary vector, and we'll try that whether this point which we would move to is outside or not. I will quickly grab my code for this. So we'll do a check on this next position first. So what I do here is I check each of the coordinates. On the x-axis, am I out of the maximum x boundary, or am I lower than the minimum boundary? If either one is true, then we do not want to move to the next direction. But so next direction's x coordinate should be the previous coordinate. So basically, do not move on the x-axis if the next step would be outside of the boundaries. Keep the old one. This transform is the axis transform, which has not been changed yet. It will be changed here later on. And the same for the z-axis. If it's bigger or the maximum boundary, or slower than or lower than the minimum boundary, then we should not move along the z-axis. We should just stay inside. Keep our original position. So after we've modified this next position, we should not add the move direction, but basically make copy the coordinates from next position into the axis position. So position copy from next position vector. And hopefully this will solve it. And instantly you can see, well, it's red, but it's trying to follow me. It can follow me on the x-axis now, but is not moving any further on the z-axis. So it's really nice, just, you know, caging up your animals. Kind of cruel, so, but they have to respect the boundaries. So now we have a scene that's completely compatible with Decentraland's inward laws. It's not coming further than 3 meters from the edges. Nice. So that's already something. Oh, at one point it seems to have clipped through the edge. So the 3 meter boundary might be a little too low. But it will always depend on the object you are creating in Blender or wherever. I can just make the axis. When I create the axis entity and add the transform component, I can make it smaller by default. So at the scale, it's also going to be a vector, and just have it, you know, half the size along all axes. So it will be half the original GLB size. Yep. Okay, so we still have some time. Let's do something interesting. Try to add the commanding or target following logic. So first of all, for this you will need inputs. You want to click and you want to register where you clicked. So after systems, I'll add some inputs. Okay, so what did I do? I initialized inputs and subscribed a button down event for the mouse pointer, and this will be very important because it's the ray casting attribute or input, which should be true in this case because we want to have a hit point. We want to have a hit point where the axis will move, so you have to cast a ray when you click, and you have to get that collision point where your click was. And then we want to do a bunch of things. So I want, if I click, I want to have a target point which is equal to the hit point, and then when I'm calculating the movement of the axis, it should not come from the player's position. So when I'm calculating the move direction, it should not come from the player's position, but it instead should come from this target position. I know this is not nice coding, but for now we'll just add a global variable called target point, which should be initialized as a vector, center of the scene by default, but we're gonna change it anyway. So we have a target point. Okay. When I click and that click hits something, the target point should be that hit point. So every time I click, I already have that point on the ground. What should I do with it? So here instead of having the player position, we should always have, let's create a target. I will tell you in a while why I did an extra variable here. Because we want to switch between following player or following the target. So we will switch this later. We could switch this between player and click point. Yep, so once you have that, all you need to do is add something that can be hit. So we need some collider on the ground. And to do that, we'll add quickly a ground entity, which will be a box. For now, to keep it simple, go back to my entities. I have one axis, and I also have a ground collider entity. So it's just a name, but basically you give it a default box shape that's inside the SDK, and you give it a transform. You want it to be in the scene center, one parcel, so right now 8 and 8 is the scene center, and scale it to 16 by 16 meters with a very low height, like 1 meters, and add it to the engine. Okay, let's see what happens. Quick reload, so the axis doesn't show up all this red. I don't like that. So here's my axis. It's not following me now, just with its eyes. But when I click, it moves to that point. So cool. You can already start making some sort of a strategic game or strategy game or I don't know, sheep herding game inside Decentraland. You can command your little fellows around here. Still looking at me though. Yeah, we didn't change that code. So inside the system we have this look at, and it's still the player's feet position. And the look at should be the target we just created inside this system. So now if I click, whoops, the X will do and go there and do this little crazy dance. Because it never stops moving, always overshooting a little bit and then going backwards, overshooting a little bit and then coming back. So once it reaches its target or gets within a certain distance, you should stop it. I think we can still add that part. I have like, I don't know, 10 minutes left. So let's see. What you want to do is have a simple function that calculates distance, and I have one just right here at the functions section. So this is a distance function that takes two inputs, one position, two position, and returns a number. So in this case it will return the distance squared between 2 points. The proper real distance involves doing a square root of all this, but it's square root is a bit slow, so just avoid as much as you can. So if you don't need it, you can use this distance squared, but you'll get a number, that's for sure. So how close these two things are, and you can compare it to another number, which is what we will do here in the system. So we are in the player file system update function. We have a target point, and we are calculating all this move direction and next position and so on, but all of that is unnecessary if we are close to the target point. So if the distance between 2 points, which is the target, and the axis position, transform that position. If these are really small, then do nothing. So if this is like only move it and only do these calculations. If it's bigger, then I don't know, like a small number. If it gets close to the target point, it should stop. Otherwise, keep on moving. Move all of this code inside this. So if we are within a certain range, just stop moving. Okay, so you see I clicked here, it didn't go all the way, but at least it doesn't doing this crazy dance. It's much better now. Yay. Go little Axie. Alright. So what we can still do is to have a switch between following me or following the click orders. For this, I will just quickly include a boolean, which is true by default. So by default it will follow me. I will use this in my system. So right now the target is always the click target point. But what if we updated this? So if the follow player boolean is true, then the target should not be the target point. The target should be the player's feet position. Oops. And all we need to do is set this true or false whenever we click or press another button, like pressing the E button. We should add it. So what will happen here? If I click, then this should become false. And the target will be the point I clicked. It won't be changed. But if this is true, then the target will become on every frame the target will update with my feet position. So this is exactly what I did here in my code. This is the mouse click. So when the mouse is clicked, then do not follow the player anymore. And then subscribe to another event button down of the primary key on the keyboard, which is E, secondary is F. So whenever I press the E button, then follow player should become true. So this way I can call the axis. Let's see if I miss something. Okay, so oops, it's following me by default. Hello. Because default follow player is true, but if I click somewhere, it will follow that point and stay there and not do the crazy dance. And if I press E again, voila, it's like calling your dog to come to you just by pressing E. Okay. So we probably won't have time to go into much more detail. I wanted to get further, but hey, this is my first try. I said we should do procedural animation, so we can give that a try, just to show you what will happen. So now I will look at my older code and add a system called Bounce. Here to the systems. And change the code a bit around here. I'm just changing it so it works with this tutorial. And let's see if it's working. Yeah, it's working. Okay, so for the last part I will just quickly go through what I mean by procedural animation and what possibilities there are if you use the code well. So this system has some amplitude and frequency for the bounce, also a time, so I know what part of the bounce curve the axis is on, and then just have another list of all the axes and transforms. And yeah, I pretty much do the same as with the movement. I gather the transform component of the entity, I gather the follow player flag of the entity. On every frame I'm raising the elapsed time variable, so that time is added up, so I know how to go through a sine wave, which we will use for bouncing. and basically, yeah, so this is the part which will actually move the axis y coordinate up and down, because it's using a sine wave. So by default, a sine wave that looks like this. I don't know, you probably know. And it's a nice floating movement. So if you just do that, the axis will float around. Here is the x-axis. But what I found, if you do an absolute value of this sine wave, then you get only the same numbers, but always in positive region. So you'll get a curve like this and continues on like this. So it will always bounce quicker but hang in the air, bounce quicker, hang in the air. And that's exactly what I did with this small snippet of code. So have the absolute value of a sine wave, and the sine wave's time is changed by the frequency you want to put in. You want the time to basically go faster, then your axis will bounce faster. And also, you want it to jump higher, then you should multiply this wave's amplitude by an amount. Like I want it to jump 40 centimeters, and it's basically doing just that. If I were to change the amplitude, I don't know, 2 meters, then I will have this crazy jumping. Probably lower the frequency, so it's not jumping as much, and so on. But it's one line of code, but it's already much more lively, or or how should I say, alive and happy. Okay, so that's it. I'll change it back to some values where this can bounce around. And don't worry, the whole code is available publicly on GitHub. I will share the link and everyone can download it. If you missed anything, then the video in its complete length will also be available. And you can try out the final code. So it's actually right next door to the community center. If you go out, I have a CryptoKitties version and in Axie version deployed. And you can click to command the axis around and press E to call them. So that's basically it. Adding more axes and adding randomness to their target positions will be in another tutorial, most likely. Okay, well, thank you all for coming. Thanks for checking this out. And I hope you create something awesome for the game jam. This was Bence checking out. Bye bye.